Now, dear student, chapter number 7, System of Particle and the Rotational Motion, and today we have the topic for the discussions, moment of inertia of a given disk. And the first subtopics are here about and find out the moment of inertia about an axis perpendicular to its plane passing through its center. Okay, about one of its diameter and about the tangent in the plane of a disk. Okay, and about the tangent perpendicular to the plane of disk. Okay, so these are the four numerical problems we have, just like in numerical problem we have. So one by one I am just making the solution of them, just please pay attention. Now first I am discussing the first problem, that the moment of inertia of a given disk about an axis perpendicular to its plane passing through the center. Okay, so this is the one of the two dimension diagram which I have shown, that we have considered the disk which having the mass, that is capital M, and it is be composed due to the large number of the particles. So we are just following the assumption that this is the body which is called the extended body, and the disk having also the concept of the rigid body. Now the radius of this given disk is from O to point P, that is called the R is there. Okay, capital R is there, and mass per unit area, sorry, the surface area of the disk is the pi r square. So what is the mass per unit length, that is called the m upon pi r square. So whenever we are just considering it, so we will use this one concept to discuss the mass of the element. So what kind of the element we can eliminate from this portion of a disk. So we are just assuming a one of the basic ring which having the width, that is called the disk, at a distance x from the center O is there. Okay, and I am also just showing you one of the basic conceptual diagram of a disk in front of you. This is the three-dimensional aspect we have. In the three dimension, I am just showing the figure to you. Now, the central portion is a z axis we have. So already we have discussed this one, but further I am just showing. Suppose this one is a x axis we have, this one is a y axis we have. So the line which is passing through the center of a disk is called the z axis. Okay, so across this we have to be find out the moment of inertia, and for the simplicity we have assumed the radius of the disk is the capital R is there, and we are just we are just imagining a element in the part of a small ring which at a distance x from the center. Okay, so this disk having its width, that is called the dx. Okay, so whenever we are just considering an element, so we should consider of its area. Okay, so in per unit area, that how much mass of this element is available. So that's why we are just assuming the meaning of the mass per unit area, okay, of the given disk. So with the basic concept we can start. Mass of given disk area of disk is equal to pi r square mass per unit area, that is called the m upon pi r square. So this is the one of the basic assumption we have. Now what actually we are doing, consider element at distance x from O of a small width dx. Moment of inertia due to a small element, that is equal to mass of element into distance square. and we are just making the mass is uniformly distributed inside the disk. Okay, so we are just imagining the integral 0 to I is there, and we are just imagining this ring is extended into O to the R portion. So many rings can be imagined from O to R, O to P is there. So we are just imagining, we are just approaching a integral from 0 to R is there. So what kind of the concept I am using here? Now as I am just, I can make the number of the elements, okay, of the different widths, that is called the dx, from the O to extended circumference. Okay, so whatever it's from O to D or whatever from O to B is there. Okay, so many elements I can imagine here. So I am just applying the limit of this integral from 0 to R. Okay, these rings are available in a horizontal plane from 0 to R radius section. Okay, so this is the basic integral which we have considered here. Now we will apply the mathematics. Now the mass of the element. So what is the mass per unit area we have? That is called the m upon pi r square. What is the area of this element? So that available in which having the mass. Okay, so we should consider the two things, length and two breadth. So we are just imagining this length element at the distance x from the O. So it having this length, that is called the 2 pi x is there. And next is their width is there, that is called the dx. So at how much distance this element is available, that is called the x square of the distance from the center O. And for the communicating for whole disk, we are just applying the limit 0 to R. Now this is the integral we should solve it. So I am just getting the meaning of the I in the left hand side, and in the right hand side I have to be apply the integral with respect to x is there. So I am just keeping all the things outside. So m is there, okay, 2 pi is there, as well as pi r square is there. So inside the integral I have only the things that is called the x raised to cube, and the dx is there. So this is the general integral which we have formed on behalf of the mass of element. So pi to pi is cancel is there. Okay, so 2 is also there. So I am just writing that 2 mass upon r square, and this integral having the value that is called the x raised to 4 upon 4, that is called the 0 to r. So the basic integral which I have used here. So I across the z dash axis, that is called the 2m upon, that is called the r square, and r raised to 4 upon 4 is there. Okay, so this is the general formula, and we can cancelize the term 2 2 so 4, r square is to be cancelled by the mr square. So we are just getting the meaning of the mr square by 2 is there. So this is the moment of inertia of a disk perpendicular to its plane passing through its center of mass or the center. Okay, so one of the result which we have got, and we will apply this one result to resolve the another problem. So this is the one of the important thing we have. This is the equation number, this is the equation number 2 we have, this is the equation number 3 we have. Equation 3 represent moment of inertia of disk about z axis, which is perpendicular to the plane passing through center. So this is the first portion we have completed. Now we want to discuss the moment of inertia of a disk about its one of the diameter. Okay. So what kind of the figure we have? Now this is the portion of a disk. So how many possible diameter we have in the plane of a disk? These are the true, A, B and the C, and this is the center O is there. So we can apply the perpendicular axis theorem by use of, so we have the imagination, this is the Iz is equal to Ix plus Iy. Okay, so here just I am just showing the one of the concept to you. This is the portion of a disc we have. So we have the two diameters are there. One of the diameter is that is called the AB, another diameter is called the CB, and this is the Z axis we have. So whenever we have discussed the perpendicular axis theorem, so we can easily say that the moment of inertia about the Z axis is the sum of the moment of inertia about the X axis as well as moment of inertia about the Y axis is there. So we can use the simplest portion, and we have the two diameters, those available on a in the plane of a disc, and they having the same type of moment of inertia. So we can use the basic concept. Iz is equal to nothing but 2 id is there, and the id is there Iz upon 2, and we have discussed the moment of inertia that about the Z axis, that is called the mr square by 2, so it comes about the mr square by 4. So this is the possible representation of that problem we have. Now the next we have the moment of inertia of disk about a tangent in the plane of disk. Okay, so how can we that represent this one phenomena? So one of the disk I am showing to you, this disk have the two diameters. So one of the diameter that is called the AB is there. If you are just imagining the tangent in the plane of a ring, so what should we do? So this is the kind of the tangent we have in the plane of a disk. Okay. So this is the situation we have. So here we can apply the basic parallel axis theorem, and this parallel axis theorem lead the concept that the moment of inertia about the line that is called represented by the sketch color is there. So moment of inertia about the tangent, that is equal to the moment of inertia about the center of mass and the and the product of the mass and the square of distance between two parallel lines are there. Okay, so this line is playing the role of a diameter is there. Okay, the AB line is playing the role of a diameter, and we know easily the what is the moment of inertia that about the diameter we have discussed here. Okay, so we will use that concept to resolve the moment of inertia about the tangent which is in the plane of a disk. Okay, so this is the concept we have. Okay, so now we are just making the mathematical calculation. So this is the simplest version which I have written here. Moment of inertia about the tangent is equal to the sum of the moment of inertia about the diameter plus product of the mass and the square of distance between the two parallel lines. Okay, so I can imagine the I tangent that is called the diameter के across हम पहले ही निकाल चुके हैं, जिसको हम बोलना चाहते हैं mr square by 4 plus mr square is there. So it comes about the 5 by 4 of mr square. So this is the simplest representation of moment of inertia of a disk about its tangent which is available in the plane of a disk. Okay, now the fourth problem we have, that is moment of inertia of disk about tangent which is perpendicular to the plane of disk. कि प्लेन ऑफ डिस्क के परपेंडिकुलर होता है, तो इसको हम किस तरीके से एग्जीक्यूट कर सकते हैं? सो वी शुड कंसिडर ए टेंजेंट which is just perpendicular to its plane. Okay, so this is the situation we have. Okay, and definitely we are just getting the third axis that is called the Z axis is there. So I am just representing the third axis that is called the Z axis in this scenario, and this is the situation of the tangent we have, which is represented by the black sketch pen. So this is the third axis that is called the Z axis is there, and now at this time I am just imagining the tangent which is in the which is perpendicular to the plane of a disk. So this here we can apply the parallel axis theorem is there. Okay, and now the moment of inertia about the line which is passing through the center of a disk, that is called the mr square by 2 is there. So we should make the emphasis about the axis from where it is passing. Okay, so whenever I am just imagining a tangent in the plane of a disk, कि मैं अगर डिस्क के प्लेन में किसी टेंजेंट को अवेलेबल इमेजिन करता हूँ, तो उसी के अक्रॉस सेंटर से पास होने वाली लाइन का रोल क्या है. तो ये सेंटर से पास होने वाली जो लाइन है इसको हम बोलते हैं द लाइन विच इज़ पासिंग थ्रू द सेंटर ऑफ मास, और इसी के अक्रॉस हमें मोमेंट ऑफ इनिशिया निकाल चुके हैं. ठीक है ना. अगर मैं इसको इसके प्लेन में इमेजिन करता हूँ तो मुझे डायमीटर के कंसेप्ट को फॉलो करना पड़ेगा, जहाँ पर दो पैरेलल लाइन में से एक पैरेलल लाइन जो कि सेंटर ऑफ मास के से पास आउट होती है, लेकिन वो प्लेन ऑफ ए डिस्क है, तो उसको मैं डायमीटर ए भी बोल रहा हूँ. एंड देन आफ्टर आई हैव द कंसेप्ट ऑफ द tangent which is at the circumference. Okay, so here we can use the basic concept, and easily you can understand that what actually I am showing to you. Okay, so this is the concept we have. Now how can I make the discussion that moment of inertia about the tangent, that is called the moment of inertia about the z axis plus mass into distance, square of the distance between the two parallel lines. So easily we know that the moment of inertia about the tangent in the perpendicular to the plane, that is called the mr square, and this is mr square by 2 and plus mr square. So it comes to that 3 by 2 of mr square. So this is the meaning of the tangential, that mean a moment of inertia. Okay, so these are the four possible parts we have. Now I'll also paste the homework to you, so you must complete this one mathematical topic. Okay.